Good morning. Today we are going to move on to another exercise of trigonometric function. This exercise is 8b. 8b. This exercise also belongs to trigonometrical identity. First exercise, we have solved some few trigonometrical questions based on a trigonometrical identity, and another exercise B also belongs to the same topic, trigonometrical identity. That means we are going to use the three trigonometrical identities, right? There are three. In fact, we made that into 9 trigonometrical identity, but we are using the trigonometrical identities, the three trigonometrical identities, to solve the question. The first trigonometrical identity I gave you was sine square theta plus cos square theta is equal to 1. And from here we derive two more. Another is the sec square theta is equal to 1 plus tan square theta. This is the second trigonometrical identity. Sec square theta is equal to 1 plus tan square theta. And from this sec square theta is equal to 1 plus tan square theta, we derived another two more trigonometrical identity. And then the last one was the cosec square theta is equal to 1 plus cot square theta. Cosec square theta is equal to 1 plus cot square theta. And from this also we derived two more trigonometrical identities. So altogether now we have 9 trigonometrical identities, right? So we are going to use those identities wherever it is possible, wherever it is required, right? So by looking at the question, by seeing the question, you will be able to understand and decide which trigonometrical identity to be used. But at times there are some questions where you will not find any possibility to use the trigonometrical identities. So in such questions where you are not in a position to use trigonometrical identity, we can solve the statement or we can solve the question by changing the given trigonometrical identity in the form of fundamental trigonometrical identity. You know, there are three fundamental trigonometrical identities: sine, cos and tan. So where the trigonometrical identity does not work, we can solve the question by converting the given trigonometrical ratio into fundamental trigonometrical ratio. So let us begin. Now this is the first question, which is where it is given sec theta into cot theta is equal to cosec theta. So prove this statement, right? Now we can start. This is the statement which we have to prove true. So we can start from one side and then we can achieve the second side. Now in the process we are using the trigonometrical identities. Now if I start from left hand side, right, to get the right hand side, because I told you yesterday in most of the question we start with left hand side. The reason is because normally the left hand side content used to be more complicated. That is why we proceed with the left hand side. But sometimes there are some questions where maybe the right hand side can be more complicated than the left side. In that case, we can also start the process from the right side. So if I start from LHS in the first step, I will just rewrite it. Sec theta into cot theta. Now, when I look at this sec theta and cot theta, I didn't find any trigonometrical identity for sec theta, right? Don't get confused. We have a trigonometrical identity for sec theta, but it was in terms of square. Sec square theta is equal to 1 plus tan square theta. But for sec theta, we don't have. Isn't it? Then cot theta also we don't have any identity. Now, since we don't have any direct identity for any of these trigonometrical ratios, I can try to solve this question by changing them in the fundamental trigonometrical ratio. The fundamental trigonometrical ratios are sine theta, cos theta and tan theta. So you know that this is the reciprocal of cos theta. So I can write this sec theta as the reciprocal of cos theta. So this will be 1 into 1 over cos theta. Is it alright? Now this is cot theta. Cot theta is cos theta over sine theta. Am I clear or not? So I have just converted this into their fundamental trigonometrical ratio, and then after this simplify, cos theta cancel. Now you are left with 1 over sine theta. 1 over sine theta. What is 1 over sine theta? Is equal to cosec theta. So is equal to cosec theta. This is how you got your right hand side. And this question is done. Is it alright? Now we can see the next question. Tan theta plus cot theta is equal to sec theta plus cosec theta. So you have to start from left hand side. Let me write this first left hand side. Tan theta plus cot theta. Now after writing this left hand side, again I realize that I don't have any trigonometrical identity for tan theta. I have this for tan square theta, right? From sec square theta is equal to 1 plus tan square theta, we can create a trigonometrical identity also for tan square theta. But for tan theta, we don't have any identity. And therefore, again, I will try to solve this question by using fundamental trigonometrical ratio. So let me write this. This is sine theta over cos theta. Plus this cot theta also we can write in the same fundamental trigonometrical ratio. This is cos theta over sine theta. Now, I will see this as the sum of the two fractional numbers. So, we will apply the addition of the fractional number concept. In that case, we will first of all find the LCM of the denominator. They don't have any common divisor. They are a relative prime. Therefore, we can simply multiply to get the LCM. And whenever we get the LCM by direct multiplication of the denominator, numerator we can obtain by just doing the cross multiplication. We don't need to go for lengthy process. Shortcut method is you can just go for cross multiplication when there is no common divisor of the denominator and you get the LCM by direct multiplication. So sine theta into sine theta will become sine square theta plus 1. This is cos square theta. Cos square theta. Now you know the trigonometrical identity sine square theta plus cos square theta is equal to 1. So we can replace it by 1. 1 over. Now this is cos theta into sine theta. Cos theta into sine theta. Cos theta into sine theta. Is this very clear? Alright. So now what we can do is, in the question, this is not plus, this is just multiplication, like theta into cosec theta. Now, after this, what we can do here is, we can write this as 1 over cos theta into 1 over sine theta. Is it okay? Now, 1 over cos theta is the reciprocal of cosec theta. So, we can write for this, we can write cosec theta. And for this is the reciprocal of sec theta. So we can write sec theta. Our answer is this. So we will write in the same order sec theta into cosec theta. Is it okay? And this become your RHS. Hope this is clear. Now let us come to the another part. LHS. LHS. 1 is equal to 1 plus cos theta minus sine square theta divided by sine theta into 1 plus cos theta. Right? Now this is your left hand side. We have to operate this, and by solving this left hand side we have to get this result as cot theta. Now we will see each and every part of this. 1 plus cos theta minus sine square theta, and then denominator is sine theta into 1 plus cos theta. So we don't have any, we can't do anything because all these are the fundamental trigonometrical ratios. We have all fundamental trigonometrical ratio. I will tell you, one identity question can be done in so many ways, right? I am trying to give you the simplest method. Now, to solve this question, I can see only this part sine square theta, for which we have the trigonometrical identity. Sine square theta, we have the identity. So we can write the identity for this. Rest will remain as it is, 1 plus cos theta minus, for sine square theta, we can write this as 1 minus cos square theta from the first trigonometrical identity. And the remaining we are writing as it is. The denominator is sine theta into 1 plus cos theta. Is this all right? Now this 1 minus cos square theta, this can be seen as the difference of a square. Why this can be seen as the difference of a square? Because this term is a square and this is 1, so 1 can be seen as anything that you want, right? For your own benefit, you can consider this as 1 square. And if I consider this as 1 square and this is already cos square theta, so then these two will become the square term and there is a minus sign. Therefore, this will be considered to be a difference of a square, and therefore we can write the factor of difference of a square, right? Difference of a square is a square minus b square, and the factor of this a square minus b square will be a minus b into a plus b. So we can write it as it is. We can write this as 1 plus this is cos theta as it is. Let you put this in the bracket, minus this will be factorized 1 minus cos theta into 1 plus cos theta divided by as it is sin theta into 1 plus cos theta. Now in the numerator we can see is that here we have is 1 plus cos theta, and here also we have 1 plus cos theta. So this 1 plus cos theta, 1 plus cos theta is common in the numerator. We can take it out. This becomes 1 plus cos theta is the common factor. This is taken out, and therefore from here you will get 1. Now from here this bracket is already gone out. Now you are only left with 1 minus cos theta, right? So you will get only 1 minus cos theta. But before that there is a minus sign. So when you open the bracket, these two terms sign will change. From here you have got 1, then this is minus sign, and now write plus cos theta. Is it alright? Denominator is sin theta into 1 plus cos theta. Is it alright? Now 1 plus cos theta, 1 plus cos theta is common, so therefore we can cancel. This 1 and this 1 also is cancelled. In the numerator you are getting only cos theta. Cos theta, and denominator you got sin theta, and therefore this is equal to cot theta, which is equal to your RHS. So is it okay now? So there are these 3 questions we have done. We will see some more questions. Thank you. All right, now we are moving on to question number 5. Once again, we will see that the right hand side, left hand side is more complicated. We will start this question from left hand side, and the first step is as usual. Repeat the first left hand side as it is. First step, 3 minus 4 sine square theta divided by cos square theta. Right, this is the left hand side. Now we have to think of the process by which we will be able to get the right hand side. Now this is sin square theta, this is cos square theta, and then we have the trigonometric identity for these two. So step by step, one by one. First of all, I will play with the numerator, right? Numerator, I can write this as 3 minus 4. And for sin square theta, we will write this as 1 minus cos square theta, right? So I can write this as 1 minus cos square theta. This sin square theta is monomial. It gives me the binomial. Therefore, I am using the bracket, okay? And then the denominator is as it is, cos square theta, right? Don't try to do multiple conversion in one step. Now you can open the bracket. This is 3 minus, now when you multiply this, it becomes 4. This becomes plus 4 cos theta, plus 4 cos theta divided by cos square theta. Sorry, this is cos square theta. This is cos square theta. Is it alright? Now we have some like term. 3 minus 4 is minus 1, and this is plus 4 cos square theta, right, divided by cos square theta. Is this very clear? Now in the next step, what we will do is we will do the redistribution of the denominator. We will do redistribution of the denominator. This denominator can be given to minus 1 and will be also given to 4 cos square theta. This is called as redistribution of the denominator. So minus 1 over cos square theta, right, and this will be plus 4 cos square theta over cos square theta. Am I clear? So what will happen? As a result, this will be cancelled, right? And this is only 4 now. This is minus 1 over cos square theta, and this is the reciprocal of sec square theta, right? So I can write this as minus sec square theta. This term is positive, so I would like to write this 4 first of all, right? Because I always try to write the first term as positive, therefore I brought it first, and then I'm writing this as sec square theta. I did this much, but my result is 3 minus tan square theta. Still I have to do something, right? So what I can do is I can apply the trigonometrical identity for sec square theta. We have the trigonometrical identity for sec square theta. Is this okay? So the trigonometrical identity for sec square theta is what? That it is equal to this is minus sec square theta is 1 bracket, because this will give you the binomial. Therefore, I am using the bracket. It gives you 1 plus tan square theta. Is it okay? 1 plus tan square theta. Because you have to think in that way so that you can get the result. After doing this process, you have reached up to this step. And now from here, what you will do so that you can get tan square theta? Then all of a sudden, I realize that sec square theta, there is a trigonometrical identity in which we are finding the term tan square theta. Therefore, I am writing the identity of sine square theta. And after this, we will open the bracket. So 4 is 4 minus, this is 1, and this will become also negative, because outside the bracket there is a minus sign. So inside both the terms will become negative. So this is tan square theta. Is this okay? Now 4 minus 1 is equal to 3, and this is minus tan square theta, as it is tan square theta. And see, this way you got your right hand side. So this is RHS, right? You have to learn the technique of how to reach to the destination. Now we have another question number 6, where you have very complicated terms on the left hand side, but right hand side the result is just 1. So what we can do? Now when I look at the question, tan A plus cot A plus into sine A and cos A. These two are fundamental trigonometrical ratio. We can't do anything because the degree is also 1. This is tan A and then this is cot A. This is also in degree 1. Therefore, so there is no identity for tan A and there is no identity for cot A. So in this part, on the left hand side, we don't see the trigonometrical identity for any one of these terms. And I told you that when you don't find any trigonometrical identity for your given terms, you can change your question into fundamental trigonometrical ratio and then try to proceed. So this is what I am going to do for this question. LHS, I will write one step as it is. Tan A plus cot A into sine A into cos A. First step is as it is. Now after this, I am going to write whichever part of this can be converted into fundamental trigonometrical ratio, we will convert that. So this I will write tan A, I will write as sine A over cos A. A is any angle, right? This angle can be anything, theta or beta, zeta, gamma, delta, A, B, C, anything, right? Now this cot A we will write as cos A over sine A into sine A into cos A, right? Now inside the bracket we can see there are two fraction numbers, so we will simplify the normal way we are simplifying the two fraction number. So find the LCM of these two. This is cos A into sine A, because they don't have any common divisor, so you just multiply and get their LCM. And in such case, the numerator can be obtained by the cross multiplication. So sine A into sine A will become sine square A. This is cos A into cos A will become cos square A, right? And then outside the bracket as it is, sine A into cos of A, right? Now you see your magic. Cos A sine A cancel. Sine square A plus cos square A is equal to 1, and therefore you got the right hand side. Hope you're getting some idea. Thank you. Now we are moving on to question number 7. In question number 7, you can see left hand side we have cos A is equal to so and so is equal to so and so. So what I will see is, I will see this as the left hand side and this quantity finally is as the right hand side. Now, which side you find more complicated? Obviously, the right hand side. And in the very beginning, I told you that normally when we solve the proof question, then we start from the left hand side, because in most of the questions, the left hand side used to be more complicated. And that is why we are beginning the process from the left hand side. But it is not the rule. If there is the complication from the right hand side, then we can also do the question from the right hand side. And this is the first question where I feel that right hand side is more complicated than the left hand side, and therefore I will start this time this question from the right hand side. Is this very clear? So right hand side RHS, I will take this as it is. First of all, this is cot A over root over 1 plus cot square A. This is a very simple question, right? Now what you have to do is you have to get this question in 3 steps. Means you start from here and then first of all you have to get this result. And after getting this result, then you have to get this result. So this has to give you 2 different results. So keep both the result in mind. So first of all, when I start this part right hand side, I will keep only this much target in my mind, that I have to achieve this. And once I achieve this, then in the next process, I will think of this another part. Am I making you sense? Okay. Now, this cot A is in degree 1, and then therefore we don't have any identity for this. For the time being, I am just leaving as it is, because also in the result I have to have this cot A in the numerator. So better I should not disturb this cot A in the numerator, because in the 2 the numerators are matching. So I will just write or copy the numerator as it is. Now I will come to the denominator. 1 plus cot square A. Do we have any trigonometrical identity? Yes. The trigonometrical identity for 1 plus cot square A is cosec square A. Cosec square A. Very simple now. Now you know that this is square and this is the root sign, so square and square root will cancel each other, and therefore you will be left with cot A over cosec A. Cosec A. This is now you have got your first result. Now from this result you have to try to get this one. So now for this cot A and over cosec A, we don't have any identity, and therefore I will change this into fundamental trigonometrical ratio. So the fundamental trigonometrical ratio of cot A is cos A over sine A, divided by this. I can write as 1 over sine A. Is this very clear? Now this sign, this fractional sign will be taken as a division sign. This is because above or below, if we have any number as a fraction number, then this will be taken as a division sign. And here in this question, your both part, upper part and the lower part also, above this and below this, both are fractional form. Both are the fraction number. Therefore, this has to be considered as a division sign, and therefore in the next process, I will change this division into multiplication. As a result, the denominator will go in the form of reciprocal. So it becomes as cos A over sine A into sine A will go up and then 1 will come down, and therefore you can simplify and finally you can get your cos A, the final result, your LHS. Is it very, very clear? Now we will move on to question number 8. Left hand side is sine to the power 4 theta minus cos to the power 4 theta. Cos to the power 4 theta is equal to sine square theta minus cos square theta. Right. Now we can see that left hand side is comparatively more tougher than the right hand side, because here the degree is 2 and this is degree 4. Therefore, we will start this question from left hand side, right? Left hand side. So we can rewrite the step. First step, LHS is equal to sine to the power 4 theta minus cos to the power 4 theta. Answer we have to keep in mind that how it is. So from here, how can I achieve this target? That you have to keep in your mind. First of all, what I'm going to do is, because our expected answer is in terms of a square, I will try to change this also in the form of a square. So then how can we write? This we can write as sine square theta to the power 2 minus cos square theta to the power 2. This can be done, no? This power is splitted, right? This power is written as 2 into 2. So one power is inside, one power is outside. Is this very clear? Now I can see that this is a square and minus b square. So is this becoming now in the form of difference of a square? Then since this is in the form of difference of a square, we can write the factor of difference of a square. Now difference of a square factor is a minus b into a plus b. So a means sine square theta. A means sine square theta. B is and minus b. B is cos square theta. Right? And then another bracket will be a plus b. So a is sine square theta plus cos square theta. Cos square theta. Now you know that there is a trigonometrical identity for sine square theta plus cos square theta, and this is equal to 1. Therefore, we can write this result as sine square theta minus cos square theta, and this into 1, and therefore your final answer is sine square theta minus cos square theta, and this is equal to your right hand side RHS. Is it done? Alright. Now, question number 9. Sec square A plus cosec square A. Sec square A plus cosec square A is equal to sec square A into cosec square A. Now, we have the same trigonometrical ratio on both the sides, but one side we have in the form of sum, another side we have in the form of difference. Is this very clear? So, how can we do it? Let us start from the left hand side, right? Because if I try to write this in terms of its identity, right? If I try to write this identity for these two, then this will give me 1 plus tan square A, and this will give me 1 plus cot square A. But I'm not having those tan or cot on right hand side. So therefore, using the, though we have the trigonometrical identity for this, using the trigonometrical identity is not giving us the result, right? So what I can do is, let me rewrite the left hand side. Left hand side as it is equal to sec square A plus cosec square A, right? I can change this into fundamental trigonometrical ratio. Let us try it that way. If that does not work, we will try in some other way also. Because as I told you that the same trigonometrical questions can be done in so many ways. And sometimes if your brain does not work, you can do it on trial and error method. You apply one method, right? You apply one concept, right? And see whether you are getting the result or not. If you are not able to get, maybe you can change the track then. So I am going to do it by trial and error method. So I will change this into fundamental trigonometrical ratio. This sec square A is the reciprocal of cos square A. Therefore, I will write this as 1 over cos square A. Likewise, cosec square A is the reciprocal of sin square A. I will write this as 1 over sin square A. Is this okay? Now, by doing so, I got this 2 as a fractional number. So, I will simplify the 2 fractional number. I will do the addition. So, cos square A into sin square A, because they don't have any common divisor. So, directly I multiply to get the LCM. In that case, the numerator can be obtained by the cross multiplication. So, sin square A into 1 is sin square A plus cos square A into 1 is cos square A. Now, I got a very good result. In the numerator, I got this as sin square A plus cos square A. For the same angle, the sum of these two will be equal to always 1. And therefore, the numerator become 1. And this is then, in the denominator, we have 1 over cos square A into sin square A. Is this okay? Now, can I separate this? Can I write this in the form of product? Right? If I write it, because I have these two in terms of product. So, 1 over cos square A into 1 over sin square A. There is no harm in writing this way, because this is going to solve our purpose. Now, you know that 1 over cos square A is the reciprocal of sec square A. So, we will write this as sec, I'll write down we will write this as sec square A, and into we will write this as 1 cosec square A, cosec square A, and this way you got your right hand side. So today we have seen some few questions from exercise 8b based on trigonometrical identity, and after seeing this many example, I feel that you might have got some idea of solving the trigonometrical identities and how to use the trigonometrical identity and where to use the fundamental trigonometrical identities, right? So you have to solve more and more sums based on trigonometrical identity. Only then you will get your critical thinking, you will get your ideas of finding out the ways of doing it. Hope it is very clear. Okay, with this we are ending the session today here itself. In the next video we will do some more remaining questions of this same exercise 8b, right? Till then your assignment will be to redo all the questions from question number 1 till question number 9. All right, so with this, thank you so much. Take care, stay at home, and have a nice day. Thank you.